Hello, this is Mr. Collier, and today we're differentiating equations with negative exponents or negative indices. Okay, so it's very important to remember that if you have 1 over x to the power of m, that equals x to the power of negative m. So we can convert things like this, which is like a fraction with x in the denominator, into something like this, which we already know how to differentiate. Okay, so in the first example, we can rewrite this equation as 4 times, this is like 1 over x to the power of 2, so that's the same as x to the power of negative 2. And now we can differentiate it using the rules that we already know. So dy by dx equals, we do negative 2 times 4 is negative 8, and then we reduce the exponent by 1, and we get negative 3. Okay, so similarly in the next example, we can rewrite this. We can just write this as, let me write like this first. 12 fifths, same as 12 fifths times 1 over x to the power of 3, which equals 12 fifths times x to the power of negative 3. Okay, now we can differentiate. We'll have, this should be f prime of x equals, we're going to have 12 fifths times the exponent, which is negative 3, and then we're going to reduce the exponent by 1. Okay, and so we can work that out. We're going to have negative 36 fifths times x to the power of negative 4. Okay, and it's worth noting that sometimes you might see something like an answer like this written as, you can rewrite this as negative 8 out of x cubed, right? Because x to the power of negative 3 is the same as 1 over x cubed. Or you could rewrite this one as negative 36 out of 5, and then x to the power of 4 in the denominator. So these are equivalent. Okay, in the next example, we've got 3 here in the denominator, so we want to make it look more like a polynomial here that we already know how to differentiate. So what you can do in this case is you can consider this to be the same as a third times 9x to the power of 5 plus 18x. Okay, so you can use the distributive property and multiply these both by a third, or straight from the beginning you could divide them both by 3. Okay, but it's important to remember that you do it to both terms in the numerator. So a third of 9 is 3, so we have 3x to the power of 5. Plus a third of 18 is 6. So then we can differentiate. So f prime of x equals, we're going to do 3 times 5 is 15. Reduce the exponent by 1. And then we're going to have, well, this is like a 1. So 1 times 6 is 6. Reduce the exponent by 1 is x to the power of 0. So it's just 6. Okay, here we want to rewrite this first. F of x equals 10x minus 4, and just like we did up here, that's going to be x to the power of negative 2 plus 2, and then we differentiate. This is going to be 10, and negative 2 times positive 4 is plus 8, so plus 8, and reduce the exponent by 1, so it's going to be negative 3, and that's going to be basically plus 0, because the derivative of any constant is going to be 0. Alright, so that's your answer for that one. Another example. In this example, again, we can divide everything by this x here. So we can rewrite this as f of x equals x squared divided by x is x. 4x divided by x is 4. And negative 5 divided by x, we'll write that as negative 5 divided by x. And then rewrite that using a negative exponent. So we write that as negative 5x to the power of negative 1. Okay, now we can differentiate. F prime of x, well, derivative of x is just 1. Derivative of 4 is 0. Okay, I'm going to write that out. Here we're going to have negative 1 times negative 5 is plus 5. And then we reduce the exponent by 1. And we get this. So f prime of x is actually 5x to the power of negative 2 plus 1. Or you could write it as 5 out of x squared plus 1.